guys. So we are going to look at the first topic in math, that is set theory. So we're going to look at the type of questions that would come in both paper 1 and paper 2. So to begin with, we're going to define what a set is and give an example. So by definition, a set is defined as a collection of well-defined objects. So that is the definition of a set. So for instance, let's give an example, e.g. we can look at a set of positive integers less than 6. So a set of positive integers less than 6, so we have 1, 2, 3, 4 and 5. So that is, you can give more examples of a set, but let's proceed with the real thing. That is, we'll start with union of a set. So the union of a set simply means uniting a set. So for instance, if we have a set A, the way we have here set A, then we've also been given set B here, then we've been asked to find A union B. We're simply saying we put together what is in A and B and we avoid repetition. So this is what it means. So this is equal to, so we say what is, we put those things together. So I'll start with A here, so I'll say A, then I'll say comma, B, comma, then I'll write, we can follow them alphabetically, then after B, then I'll go to C, there's C in this other one, so I'm getting the C here, then I'll say comma, I'm done with the letters. Now I'm going to go to the numbers. Now here is one thing you need to observe. We have A in this set and we have A in that set, so I am not going to repeat A, I'm just going to write it once. So since I've written all the letters, I got the numbers. The smallest number is 2, so I'll say 2, comma, followed by 3, comma, and here you're also going to notice that 3 is found on both sides, but I'm just going to write it once. Then finally 4 here. So this is how you can write the union of a set. You just put together the members of both sets and avoid repetition. Okay, we are also going to look at what we call intersection of a set. Now what do we mean when we say intersect two sets? So to intersect a set, this is what we mean. So we have set A, which is having members A, B, 3, and set B, which is having members 2, A, C, 3, 4. So when we say the intersection of A and B, we're simply looking for those elements that are found in both A and B. Look at what will happen here. So A is found in set A, and A is also found in set B. So I'm going to write A here because it is found in both. Do we have any other element that is found in both? 3. So 3 is found here, 3 is also found there. So we say comma 3. So you discover that only A and 3 are found in both, so those two are going to form the intersection of A and B. Alright, we now proceed to the complement of a set. What do we mean when we say the complement of a set? We're going to understand this by looking at an example. That is, if we have set E, by the way, set E represents the universal set, and a universal set is a set that contains all the elements. So all the elements are part of the universal set. You can prove here, check, you discover that all the elements which are found in set A are part of the universal set. So now, so we've been given the universal set and we've been given set A, then we've been asked to find a complement. So what do we mean when we are asked to find the complement of a set? The complement of a set, this is what it means. It simply means apart from, complement means apart from the elements found in the given set, but all the elements found in the universal set. This is what I mean. In set A, I have 4, so I go in the universal set and I cancel out the 4. In set A, I've got 6. I go in the universal set and cancel out the 6. In set A, I've got 8. I go in the universal set and cancel out the 8. In set A, I've got 10. I go in the universal set and cancel out the 10. Then whatever remains uncancelled forms a complement. So you have 1, 2, 3, 5, 7, then 9. So those are the ones which have not been cancelled. That, and that. So this is what constitutes a complement. Right. If you don't have any challenges here, we proceed to the next segment, which is combined operations. Now, combined operations simply means we look at the combination of what we've been doing. You can have intersection and complement in the same question. For instance, we've been given set E here, so which is a universal set. We've been given set A, we've been given set B. Then we've been asked to find a complement union B. It simply means you first have to find the complement of A, then unite it with B. So let's do this. I'm going to solve this question one by one. So I'll say, so this is what I'm going to do. So what is a complement? Let us start with a complement. A complement simply means apart from the members of set A, then include those of the universal set. So check a complement. I'm going to cancel out the x here, cancel out the x there, cancel out the z, cancel out the z there, cancel out the 2, cancel out the 2, cancel out the r, cancel out the r, cancel out m, cancel out m. Then what remains is 1, 3, 4, a, b, k. So that is what remains. Then this is being united to b. So set b is x, 3, m, k. So if you unite these things, we are simply putting them together. So without repetition, I'll start with numbers, then letters. So the numbers we have 1, then 3, then 4. 3 is appearing both, but I've just decided to write it once. In fact, you're supposed to write it once. Then you go to the letters. You start with alphabetically A, and go to B. Then we don't have C. So K comes first. Then you go to M. So that is what forms a complement union B. So this is what we have here. So you just pass through to ensure that the workings are okay. Then let's look at this other one, A intersection B complement. So we'll start with set A. Set A was x, z, then 2, then r, m. So that was set A. Then we are intersecting it with B complement. We remove what was in set B. So here I'm going to use a different color so that you can see. So in set B we have x, so the x will be cancelled. In set B we have a 3, so a 3 will be cancelled. In set B we have m, so the m will be cancelled. In set B we have k, so the k will be cancelled. So all those that have been cancelled with the color blue are not going to be considered. We only consider those that don't have that color. So we're going to start. B complement will have, so I'll say 1, 2, 4. Then I go to the letters. So A, B, then R, Z. Okay, that is what we have. Then to intersect we are simply finding what is common in both. So we are trying to intersect them. So what is common? So you discover that what we have in both, we have R in both. Do we have anything else that is there in both? X is only found in this other one. We have Z. Z is also found in both. We have 2 is also found in both. So I'll start with the number. So 2 is found in both. Then R is found in both. Then Z is found in both. So that is what constitutes the intersection of those two sets. So ensure that you follow through the procedure and check if my workings are accurate. But that's basically how you go about the procedures. Right. We now look at the last part, which is Venn diagrams. So now, in looking at Venn diagrams, we're going to look at Venn diagrams. So we'll look at 2 questions that involve Venn diagram. So we'll start with the first one. So the first one is on shading. Shade X complement intersection, then Y intersection W on a Venn diagram. So how can we shade such a set? So the first thing that you should do, you first understand how many letters are involved. So 3 letters involved. We have X, Y, and W. So you draw 3 intersecting sets. So I'll draw this one, then I'll draw that one, and I'll draw that one. So you draw 3 intersecting sets. Then you name one X, name the other one Y, you name the other one W. Okay, so that is what you do. So we have that, we have that, we have that. So that is what we have there. So now we know we are going to put E to mean the universal set here. So that is what you do basically. Then now you start with the shading. So how are we going to shade? So I'll use different color to shade. So now inside the brackets we are looking at the intersection of Y and W, but the X apart from X. So have you said, so apart from X, but we intersect Y and W. So when we say X complement, then we are intersecting it with that. So Y intersection W. So look at Y is here, W is there. So this is the intersection of Y and W. I want you to check it. This is the intersection of Y and W. But we are not interested in the X part. So the one that carries the X is not supposed to be there. So just remove this part, and the only part that we're interested in is the one that contains only the intersection of Y and W. So this other one is the X complement. So we need this part. That is the part that we need for the intersection. The part that we need for the intersection. So that part, like that. So that simply means we have shaded X complement. As you can see, there is nothing that has been shaded in X. It means complement. Then we've intersected it with Y intersection W. So that is how best you can go about that one. Then we look at the last one. Find Y in the diagram if number of elements in A union B is equal to 27. So how can we find Y if A union B is equal to 27? Meaning we are putting these two together to unite. We are putting things together. So I'll say we have Y, then we're adding it with 6, then we are adding it with 14, then we are saying these should give us 27. So those should give us 27. So say Y plus 6 plus 14 15, so it is 20, then that should give us 27. Y should be equal to 27 subtract 20, and what we get, we know to say when 20 crosses the cosine, it becomes negative. So 27 minus 20, we get 7. So this simply means the value of y here is 7. So that is how best you can go about this one. Now, hopefully, I'm going to give a question. Yes, so I'm going to leave a question that you can try out. All right, so try out these two questions. Try out these two questions and see how best you can go about them.